Hello everyone, I'm Joe Marigabad and today I'm going to demonstrate my understanding of computer assembly. Why PC assembly matters. It can help us learn how different components work together inside a computer. It helps ensure safe and proper installation of hardware, and it can build confidence in troubleshooting and upgrades. What are the major components in the system unit? The first major component is the CPU. It is the brain of the computer that processes data. The next is the motherboard. It is the main circuit board connecting all components. The random access memory, or RAM for short. It is a temporary memory for running programs. The storage devices, which is the SSD or the HDD. It is a permanent memory for all files and data. The next is the power supply unit, or the PSU. It converts AC power to DC power for components. The next is the graphics processing unit, or the GPU. It handles all visual and display processes. The next is the cooling fans. They intake and exhaust for airflow in the system unit. The heatsink fan, it is responsible for cooling down and making sure that the CPU doesn't overheat. And lastly, the case, which houses all the components inside the computer and protects them. First of all, where is the motherboard mounted inside the system unit? It is mounted inside a case, typically on standoff. All parts plug into it. What is its importance? It provides data pathways between CPU, memory, storage, and peripherals. It contains chipset that controls interfaces, has connectors to input or output, which are USB, audio, or network. And the next is the CPU. Where is it placed inside the system unit? It sits on the CPU socket on the motherboard, typically under a heatsink fan or a liquid cooler. What is its importance? It performs calculations, logic, control flow, communicates with memory, storage, GPU, and input or output via buses. Generates heat, so cooling is critical. Next is the RAM. Where is it placed inside the system unit? It is inserted in the DIMM slot on the motherboard. It's important because it provides fast access for CPU to read or write active data. Slower than CPU registers but much faster than storage. More RAM allows for more or larger applications to run simultaneously. Next is the storage. Where is it located? A 2.5-inch SSD or 3.5 HD 3.5-inch HDD in drive base or mounting brackets, NVMe SSDs in M.2 slots on motherboard or on PCIe adapter, SATA or power cables connect to motherboard/PSU. Importance and connections: it holds data even when power is off, slower than RAM but higher capacity. Speed greatly affects boot and load times. The next is the power supply unit or the PSU. It is mounted usually at the back top or bottom of the case. It supplies stable voltage to motherboard, CPU, drives, and GPU, has multiple connectors, and power rating must match system demands. Next is the coolings or the cooling fans or the heat sinks. The CPU is cooled by heatsink or fan. Case fans intake and exhaust for airflow, and the GPU usually has its own cooling. The importance is that without cooling, components will overheat and fail or throttle. Airflow paths, thermal design matter. Next is the GPU. It is either integrated on the motherboard or the CPU or as a separate card in the PCIe slot. Connects via PCIe lane plus power connectors if high-end, power ports on rear of case. The importance is that it offloads graphics tasks from CPU, especially for gaming, design, and video, requires high bandwidth and often power. Next is the case. The case houses and protects all components. It provides physical structure and airflow for cooling, includes mounting points for motherboard, drives, PSU, and fans, and its connection is that it holds all part in place and allows cable management. So in summary, each PC part has a specific and vital role. Proper assembly ensures reliable performance. Understanding connections builds real-world textiles. That's it. Thank you for listening.